All right, so I'll continue with the data deluge and the HDF5 imperative. So why are we here and why HDF still matters? So it's kind of piggybacking up what Garrett said earlier. So we know there's an explosion of data. For example, uh, it's estimated almost 500 million terabytes per day is going to be generated in 2025. And a lot of that is stored on cloud storage. So it's projected that there will be 100 zettabytes of data stored in the cloud by 2025. And of course, the main players are Amazon, Microsoft, and Google. So if you plan to join the cloud, it's best to have those support on those platforms. In terms of scientific data generation, it's estimated that scientific data is growing at a rate of 40% per year. And then, of course, we all know about AI, and we have to now support that as well, and that's very data hungry as well. Why HDF matters, of course, AI, as Garrett alluded to in his talk, that we want to be very capable and have an impactful service for those people doing AI and ML workflows. HDF5 has advantage that enables rapid loading of large training data sets. It also allows you to select individually if you want to do a subset of a data set. And all these are very crucial for doing iterative model training. In terms of what the HDF5 itself offers, it's because it is storing and organizing the data for complex material. It allows embedding, model parameters are clear, and you can discover that data in a trainable way. And then that will lead you to doing potential for knowledge graph integration for richer metadata, provenance, and data discovery. So nowadays, it just goes beyond using HDF5 to get good performance. HDF5 has to be part of a workflow. And nowadays, essentially, you have the experiment observation stage, the data analysis stage, and the simulation modeling stage. And at all three of those stages, it helps that HDF5 interacts between those two and flows and works within the workflow itself. So some recent innovations of HDF5, I'll start off with 112. So in 112, we introduced the vol layer, which is basically an abstraction layer that allows you to not have to get into the guts of the HDF5 library, that you can design your own interface to do whatever you want, to interact with, for example, with new storage systems or interact with the cloud. This allows it to be very extensible, future-proofing, and allows you to do your own custom storage solutions. We also, in terms of enhanced data access, we increased the hyperslide performance. So for example, we had a use case that we wanted to read every 10th element of a data set, and we did improvements that we saw that we could improve that operation 6,000 times over what it was previously. We also added ability to refer to attributes and objects in data set selections that may reside in another HDF5 file. And then finally, we keep up pace in that version with introducing token types in 64-bit selection. What this allows you to do is a lot of the vols don't have the concept of an address space. So what we introduced was token to allow the vols to be more inclusive of using or being aware of what vols are doing. So with the end of 112, now we're into 114. And the big addition was in 114 was the addition of asynchronous APIs. So the underscore async, the APIs with the underscore async. So the impact was if your application can be improved, if you don't have issues with concurrent I/O needs, which is critical for HPC. So this is just one, make sure. This is just one case that we're using. No, I don't, sorry. That we have an application that this is the time step it took. So 1 through 35, and we observe the write time, and then the blue lines are the synchronous I/O, and then you can see that with async I/O, you can basically hide the I/O I/O operations during the compute phase. And then at the end, it catches up with itself because it didn't have enough to hide that overhead. But it definitely improves the performance you can get from your I/O. Of course, there is trade-offs. If you use async I/O, you can either copy that buffer that you're going to write later, or you can rearrange your algorithm so that you can hide that using that array, overriding the array before it's written. Another feature that we introduced was multi-data set, which is H5D read multi and write multi. This definitely helps performance because it essentially combines what you would have if you had, for example, if you were writing the components of an array, which is X, Y, Z, instead of doing 3 different write calls, you can then combine into doing 1 write call. And as you know, parallel file systems do a very good job with writing large data sets instead of individual smaller data sets. We also introduced subfiling and Onion VFD, which was talked about earlier. In terms of subfiling, it's just a way to essentially write subfiles, for example, to if you have no local storage, you can write to the no local storage for a subfile, and you can do that across the whole machine. And one of the benefits of doing that, as you can see, and this is taken on Frontier at Oak Ridge. So this is the number of nodes that is increased from 128 to 4096, which is about half the machine. And if you're using the no local storage in the purple there, you can see that it basically is the theoretical peak. So at half the machine, we're getting about 16 terabytes per second. If you were going to Lustre storage, you decreased to around 3 terabytes per second, which is a little bit less than the theoretical peak. But subfiling gives you a definite advantage when you're doing at the exascale. And then finally, we keep updating our APIs with, for example, iteration over data chunks. And then we also add an API for compatibility macros. So going on to the ecosystem and the community in HDF5. So we know that HDF5 is more than a library. It's just, we have tools of the trade, and one in particular is HDF View, which is a go-to visualizer for a lot of scientists. And we try to keep the updates to the changes in the library updated to reflect that in the HDF View. So for example, we now support float 16 that we recently introduced, and then complex number types. We do have a survey up on our website, and this is a link if you download the presentation. And we ask about HDFU, our users, whether you use it or not. It'd be great if you could take that survey. But one thing that I extracted from some of the survey answers already was how do we improve the usability and performance of HDFU? So a lot of the suggestions was focused on easier data viewing, drag and drop type of functionality, handling large data sets. I'll talk about that here. And then be a more data studio-like environment. So in terms of large data sets, we have on our radar, or our roadmap, is that we would like to be able to cache data sets. So now if you load a data set in HDFU, it essentially loads the entire data set at once. But it'd be nice to be able to, instead of doing that, to load the part that you're actually viewing, and then cache if you're going to scroll down or scroll up, for example, and then bring it into the cache once you start to visualize the data. Some other viewers in is H5 Web, Silex, and HDF Compass, little highlights there. And more about that will be talked about tomorrow in John's talk from the HDF group. So there'll be a round table talk from representatives of those packages tomorrow, and they'll discuss some of the history, the features, the intended use, and the future roadmaps of those packages, and then have an open discussion on what the future steps would like to be. So that'll be tomorrow. In terms of HDF4, I don't know, probably not a lot of people in this room use it, but it's still a part of the family. Its latest release was 3.0. In that release, we had significant major internal code changes and restructuring. And basically, that was to eliminate the exposure of internal components to the applications. We also modernized the build system and removed the XDR dependencies by implementing a stripped down version of it. We also updated the modernization of the tools. We removed some outdated utilities such as NCGen and NCDump tools that were available since 1993. In the upcoming release, we are planning to do some additional code cleanup, but not to the extent that we did in 3.0. And that release is also focusing a lot on improving the memory sanitization issues that we discovered, and then updating the documentation to reflect what the current library's behavior is. In terms of continued support, as the satellites that are, NASA is particularly interested in HDF4 because they have still satellites that are pumping out HDF4 data. But as those satellites go offline, NASA's interest in HDF4 starts to waver. And so we do see the support of HDF4 drifting more in the direction of greater community support. In terms of how we are trying to empower the community to drive HDF forward, we do have, for example, this user group that we put on with roundtables. I think that's really helps get feedback to us and helps in collaboration with us. We also have a working group meeting that meets on a bi-monthly cadence, and this usually involves more detailed discussion of library development and roadmaps. But anyone is welcome to join the discussion, and we encourage you to do so. It's all on our wiki. It's the link there. If you download the presentation, brings you to the talk about the working groups. And we continue to strive at the HDF group to be an open source nature, and we hope to encourage more contributors to the source code itself. We really view ourselves as stewards and in the development of HDF5. And as Garrett mentioned, we are starting an HDF5 Alliance with the link there. So it's basically a way to secure the future of HDF. So it's establish a community-led governance to broaden the funding, the scale of development, and just to ensure the long-term sustainability of the project. So the main goal is to empower the community. So it's to give users a direct voice into HDF's direction. We also plan to introduce a new concept, to us at least, is to what we call the HDF5 enhancement proposals, HIP. This is going to replace, if you saw in our previous presentation, a lot of people mentioned the RFCs. This is going to replace the RFCs so that we actually get more community feedback and more governance for that procedure for how you would propose a new extension for HDF5. And as Garrett mentioned, we'd like just to go beyond the data scientists, but actually the scientists, so we can get their use cases as well involved in our discussions. So this is the governance initiative. I provide a link there. It's open. We're hoping to attract, as I said, users, developers, or any just stakeholders that are using HDF5 that have an interest in shaping the way the governance is going to work out. In terms of other supports, we do have a help desk, and it's very heavily used. So we resolved in the past year 176 general help tickets and 42 priority support tickets for those people the companies, for example, organizations that need quick turnaround to resolve issues they're having so that they can move forward with their product or their customer issue. We also have the HDF group forum, which I'm sure a lot of you are aware of, but it's very thriving. It has had 236 new technical discussions, and it had almost 1,000 posts that year, and we've also welcomed 104 new users. So it remains a very valuable tool for us. We also, I don't know if a lot of you are aware, but we also give what we call a call to doctor, which is a community type session every week. And it's more information is on our website, but it's essentially it's your chance to ask the engineers at the HDF group questions that you might have. If there's no questions, sometimes the engineers give a topic, give a presentation on a topic that they think the community might be interested in as well. So let's just go into the current strengths of HDF5 and address some challenges that we have. So the current strengths, of course, and this has been alluded to in previous talks, is that it really is pretty good at handling petabyte scale data type. size data sets. Yeah, I think it offers unparalleled scalability for handling a lot of these research challenges. As Garrett mentioned, it is fair oriented, so it's a way, since it does have very sophisticated metadata capabilities, fair just kind of falls out from the use of HDF5. And of course, it is supported by a lot of universal languages that are used in scientific computing. For example, the Python, MATLAB, Julia, C, C++, Fortran. And this also ensures that you can talk across uh, colleagues and across disciplines in using different tools. Some of the hurdles that we currently are coming across is the complexity. For one, we get a lot that from a user. So the format's power stems from its complexity. So as Garrett has mentioned and Mark has mentioned in his discussion, is that you really need the documentation to be up to snuff when you are talking about such a complex library. Another thing is performance. We spend probably about 80% of our time on answering performance type questions or resolving performance issues compared to actually doing implementation of new features. So performance remains a very uh, important aspect of our jobs. Another is cloud integration. Historically, we haven't been, this has been challenging for us, but I think as you'll see in the talks you saw today and then some talks by tomorrow, we are addressing that. In terms of security, we are proactively patching CVE issues, and we are, for example, in the 114.3 release, we were CVE free. We also came across some security issues for the H5D read chunk, and we have resolved or in the process of resolving that security issue, and that will be released in the 2.0 coming up. And lastly, a great challenge for us, because we do a lot of CI testing now. We've moved from on-prem to off-prem, especially on GitHub, to test the newer version HDF5. Where this becomes problematic is that we have hard time finding hardware that is old, such as big Indian machines and 32-bit. So testing on those machines is becoming very challenging for us to do, especially as our on-prem of those machines go away. Going back to the documentation, so we've enhanced our documentation support site. So this is on the right here. We did have different namespaces before. We had the docs and the portal, for example, and we eliminated all that. Now we just have a support.hdfgroup.org site. And that essentially, as you can see, has all the categories all at once linked, and you don't have, and they all point to the same namespace, the support namespace. And we have been striving to improve the content quality, as was mentioned, but that's an ongoing process, and that basically comes down to who has the time to do it and the funding to do it. Saying that, we have moved on to a living documentation approach for our documentation. So we're treating the documentation as dynamic, and it's just continuously evolving. So we recognize that the importance of up-to-date documentation for our users. So we decided that the documentation should not depend on a formal software release. So moving forward, then we just have one set of documentation, and which will have dedicated links, and then the expected content on that in that documentation will be regularly updated, expanded, and refined, and they'll be all independent of the cycles of a release. So going into the future of HDF5, we have been trying to be more transparent about what's going to get released in the next version of the library. So we want to be very upfront with the community about how we're triaging, tracking, and then what our release roadmap is. So the first, if I just want to discuss the triage of an issue. So as it comes in, we now push that issue to the triage. And in the HDF group, we have a set of leads that are responsible for different components of the library. For example, you have a lead that is responsible for monitoring the C library, the documentation, the parallel components, the build system. So those leads will look to see if any of these issues need to be triaged, and if they do, they'll take care of that, hopefully within the week, if not within a day or two. So issues as they come in on GitHub will be quickly triaged. And then we are using release gating roadmap. So this shows issues grouped by the release priority. So when we triage it, we will assign it whether it's a release blocker, meaning that the release can't go forward without these being resolved. We will also have a category for release in the future. It would be nice. Those would be kind of features that we mark as they would be nice to be in the next release, but it can be pushed down the road to another future release. And then finally, those issues that come in that just can be deferred for a release in some future one that we just don't have the resources to do. So once you have the roadmap, you can also track, for example, when those issues are triaged, and then you can track whether their current status of an issue. For example, in a release blocker, you can see if it's still on the backlog, whether it's scheduled to be done, whether it's in progress, or whether it's done itself. And all this is now, if you go to our HDF group/projects page, you can see this all now online. So if you ever submit an issue, you can kind of track now and know instantly whether it's going to be in the next release, who's working on it, what state it's in, and so forth. So hopefully this really helps our users track more so than maybe in the past of what's going to be in the next release. In terms of the next release, which is 2.0, of course, you'll notice that it's 2.0 now. We're switching over to semantic versioning, and we have a wiki page. We used to have this information on on our forum where we asked users to what would you like to see in the next 2.0 version. We've since moved that to the wiki page, and you can find that in the HDF groups HDF5 repo on GitHub. Some of the the higher level ones, as mentioned, previous speakers, that we are introducing optimized the library defaults for better performance with the cloud computing. So for example, we increased the chunk size from 1 megabyte to 8 megabyte. We also increased the page buffer size, the cache size when ROS VF3, the ROS VFD is used, and I'll talk about that in a moment. And then finally, the one you might really notice change is that we've dropped Auto Tools support. So now we will only be building with CMake builds going forward, and that's with 2.0. In terms of the wish list, we maintained that on our wiki as well. So we have some big items that people have put as suggested, such as journaling, better Unicode support, multi-threading support, sparse data sets, for example. And of course, you have a list of smaller things that I just kind of cut off there. But if you'd like to add your wish list or to this, you can edit the wiki. In terms of high performance computing then, as I mentioned, we were involved with in the Department of Energy's initiative to do exascale computing. So what came out of that project was certain VOLs that are very good at exascale. So as I mentioned earlier, you have the async VOL, which can do the async operations. You can couple that with a cache VOL, so it can move in and out different memory, and you can use that in conjunction with the async VOL, which gets you very good timings for I/O. There's also a log-based VOL that, depending on your I/O patterns, can help your performance. And then we have the Deos VOL, which is going to become in play, for example, on Aurora at Argonne. They're now having a production system that has the Deos. As I said, I think we get very good performance at exascale, and we are continuously addressing as the exascale systems become production-wise throughout the national labs. We try to address performance issues as they come up. We also are integrating for vol developers, we're updating our vol testing. So we did have an external repo test for testing the vol. We've since moved that into the HDF5 library proper, and we're now moving the tools into the HDF5 library as well. And hopefully this will be an improvement for not only HDF developers, but then people that are using vols to make sure that the vols support and work on their systems. We're also working on improving the performance of the VDS feature. So this is an example of opening a million virtual data sets, and the performance of doing that was greatly improved, almost by 50% with before and after. And so this optimization will also go into 2.0. In terms of ML and AI data, we've added new data types. So this is a way to simplify some of the ML and AI development. It's basically for convenience. We introduced some new predefined floating point data types that are common with ML and AI. So this is just the tentative names that we've come up with to introduce these new data types. So for example, in your next gen AI data types, if you want to write a float 16 data type to a data set, before you had to do 6 different operations to write that data type, because you'd have to define it yourselves. And if you're going to use the predefined floating points, that's just now, you can just eliminate all that and just call the data set type in your H5D create call. In terms of cloud optimized, we are developing the read-only S3, the ROS3 VFD improvements. So if you're using that, we are planning to replace the S3 backend using the AWS C3 instead of what we're currently using for libcurl. What that gets us is it's C99 compliant, it's maintained by AWS, so release some of our maintenance burden. It's also distributed by several package managers, so it's very easy, but if it's not, it's very easy to build, and it's really designed for high throughput. Some motivation for doing that was the current backend kind of had shortfalls in the terms that it didn't really attempt to parallelize the requests. It didn't parse the XML responses from S3. It also didn't allow for querying any standard AWS configuration files or environmentals. And we had to implement an ad hoc system of forming the AWS authentication headers, and with that had a maintenance burden for the future. So with this new addition, it now has robust error handling, so we can do automatic XML parsing and management of the S3 responses. It also improves the parallelization because large S3 requests now are automatically split, and that improves the faster data transfers. We also have now seamless credential management, so it natively pulls from different files the standard sources that you typically have for AWS. It also now directly supports S3 style object type URLs. And some additional enhancements includes DNS, load balancing, efficient networking, resource management, and support for future async I/O. Some of the considerations and trade-offs then, of course, the maintenance complexity kind of went up because AWS, while it has documentation, it was still kind of lacking. So it's very challenging keeping as a back-end maintenance. It also introduces a third-party dependency that wasn't there before because libcurl is pretty much available everywhere. In terms of filters, we're researching how to secure those filters and plugins. So the motivation is basically to provide a way to prevent data to be compromised. So we want the users of these filters to be sure that they haven't introduced any malicious code. In order to do that, we're looking into adding digital signatures to filters, and we are planning to use OpenSSL. So how this would work is you would build your HDF5 library, and you can set your security levels to be off, worn, and strict. So off means that it wouldn't check for the signature of a plugin that you're using. It would just go ahead and use it. If you didn't have it set to strict, it would look for the signature of the filter. If it doesn't match or it's corrupted, then it wouldn't allow you to go on, and it wouldn't throw an error essentially. What this allows is just users to verify that the authenticity of the plugins is correct. And this is really important. For example, as Mark showed earlier, if you're doing the medical field, they want to know that you want to have a transparency of your filter. So you want to know that that's been signed, that it hasn't been corrupted, or it can leak data out to the outside world. More details will be in a paper that we submitted to IEEE at the eScience 2025, and I have a link there. And this is a project that's funded by the NSF. So it's pretty much a prototype now, but it would be nice to have a production version of this solution as well. And we are involved in supporting open source projects that rely on HDF5. So I think it's not only good that we provide our software for free, but we also help other organizations that are using HDF5. One organization that I'm particularly involved in is the CFD General Notation System, with CGNS for short. It's a way to standardize fluid dynamics data. What we did was we switched the CGNS documentation and website to use Doxygen and Sphinx. We also are looking into improving the exascale performance of CGNS by tuning its application by using subfiling, multi-data set, and also introducing compression into that library. And we are members of the CGNS Steering Committee. We also are co-maintainers of the ZFP compression plugin. And we also work with, if we find that a release hampered or blocked certain packages, then we try to resolve that pretty quickly. And then we had to do that for CondaForge with the 1.14.5 release. They had issues with that, so they have a roadblock. So what we did was release the 1.14.6 so they could keep moving on. So it didn't provide a roadblock for them. So engaging with the HDF community, as I mentioned, it'd be great if you can participate in our HDF forum, our working group, and on GitHub itself, the wiki and such. You might consider the HDF group as a resource partner for your next proposal or grant. As Garrett mentioned, we would like your input on our new governance and HEP framework and the links there. And then just general resources for learning. You can find it on our website or documentation and our tutorials. Just to sum it up, we think that HDF5 needs to be, as Garrett mentioned, more community driven. We want to speak more about to our users and what their needs are, as opposed to just moving forward with features without any direction. And for that, we need to be more collaborative. So thank you, and just a couple of acknowledgements there.